Hi everyone, I'm Erin and this is Sarah, and we're here today from NDSU Extension here in Bottineau County. My role with Extension here is family and community wellness, so I help people with health and nutrition and food questions. Sarah's role as the agriculture and natural resource agent helps people with agriculture and livestock questions. We're presenting together because our jobs actually go very hand in hand. We both require a lot of STEM, science, technology, engineering, and math to do both of our jobs. So today we're going to be talking about measuring the wind.
And so when we're talking about measuring the wind, we're actually talking about wind speed. And so a lot of people think about miles per hour or kilometers per hour if you're in Canada, which is just to the north of us. But we're going to actually talk it in revolutions per minute today, just because we don't have a radar or sonar to tell you how fast these things are actually spinning. But we're going to actually construct with you today a couple different anometers. So ano comes from the Greek word ana, meaning wind. And so that's where we have anometer, which is a wind meter essentially. And so we're going to build a couple with you guys today, and Erin's going to actually build one with you, so that way you guys have an idea of kind of what you're building. These are just examples. So we have a 3-fin anometer, a 4-fin anometer, and a 5-fin anometer. So in your worksheet packet that you guys got, it talks about the difference between a 3-fin and a 4-fin. And so we call them cups because we have actual cups on one of these, we have spoons on another, and we have actually pieces of an egg carton for the other fin. So you can see that there's 6 of them missing here. And so you can use just about any material you want to construct your anometer. And so in your kits, I know they have, things like cups and some dowels or some skewer sticks or things like that. But you can essentially use anything that you have laying around your house or your classroom to construct these with. So you can see we have a bowl with a cup, we have a vase from flowers, so anything you can want just to get it to stand up so it can withhold the wind. And then you'll use a fan as your wind source. And so there's a lot of science and technology behind the evolution of an anometer or wind meter. Sometimes we see a lot of wind meters and anometers out in fields, especially as we drive past. If you go towards Rugby, you'll see the big wind towers and things like that. They have the same concept and same design. And so we're going to actually do some testing between a 3-fin and a 4-fin, or 4-wing or cup, whichever you decide to use as your capture for the wind. And so some other examples that we have of wind meters is, just these pinwheels, easily blow in the wind. So this one, if I move it up and down, it'll actually go pretty fast. So there's lots of examples of lots of different fins. So this one actually has 1, 2, 3, 4, 5, 6, 7, 8 different fins on this one. And so you can get as creative as you want with this project, or you can be as simple as just using, spoons and a styrofoam cup. And so Erin's going to actually walk you through how to make one. And so she is using a dowel as her post. She's going to stick that into just a vase. We stuck some paper towels inside the vase just so it stands straight up and down, so it doesn't wobble back and forth. So if you get them, they get kind of wobbly otherwise. And so you'll kind of see that when we turn on our examples, when we turn the fan on. So that's the first step. The next step is she's using a cup to help hold the fins. So this is just a basic 8-ounce styrofoam cup. And then a pin is going to get inserted into the very middle of the cup. Styrofoam cups are nice because they usually have a little dimple on the bottom that shows you exactly where the center of the cup is. Some of our plastic cups don't have that, but they'll work. Just get it as close to the center of the cup as you can, and then you're going to push that right into the middle of the dowel. And so you can put the dowel into the cup, into the pin first before you stick it in, or like Erin did, after it's already into the vase or bowl or cup or whatever you're using to help hold it upright. And so for our fins on this one, she's using a spoon. So this is just a plastic clear spoon. This one here that I have in front of me has white spoons. Again, you can use little cups. So we have, these little like Dixie type cups that you can use for like punch, things like that. In Walmart and things like in other stores, they have little condiment cups. So like things that you would get like ranch dressing or salad dressings, ketchup, that kind of thing. So that works really well as well. You can actually even use the lids. So anything that will help capture the wind just to make it spin. So any of those type of things will work. And so she is creating a 4-cup anometer. So she's going to put her spoons in. So she's going to start with putting one in. And you can put them at the top of the cup, at the bottom of the cup, in the middle of the cup, kind of wherever they work best for you. And so to make a 4-cup Animeter, you're going to want to have your spoons facing perpendicular to each other. So you're going to have ones that go exactly opposite each other, and then ones that are exactly opposite at 90-degree angles to those two that you just put in. And so that'll help make sure that you're capturing wind from all the different angles. Because we all know how wind blows. It doesn't blow in one direction all the time. And so the Animeters need to be able to capture it from whichever way the wind starts blowing first. And so she's sticking her last spoon in there.
And the nice thing with Styrofoam, as Sarah mentioned, you guys can use Styrofoam cups, but we also have the egg cartons. And so the nice thing is that toothpicks and spoons, they all can just be pushed right in, and you can kind of practice using, like Sarah said, we have 3 and 4 is the one I put together here today, but you could do all the way up to 5, 6, 7 if you really want, quite easily.
Yep. And with Styrofoam too, they easily stick through the side of the cup. Whereas you see in this one up front here, we had to use masking tape because the plastic just doesn't, you have to cut them and it starts to rip almost like a piece of paper once you start cutting into them. So that's where Styrofoam is extremely nice. And so once you get it constructed like that, the best thing to do to make sure that we're able to count how many revolutions, so how many times it goes around one point is how we're going to count this, is we use just a sticky dot. You can use a sticker, you can color it with a marker, just something to make one of the fins different than the others. And so you can see here we have blue dots on all of ours, so we can tell every time that that one passes a certain point, we know that it went a entire revolution. And so Erin can stick out whatever color she wants on her fin, so that way we can tell which one it is going to, or how many times it turns in each revolution. Okay, so it's simple and easy, and you can definitely see that there's a yellow dot on her spoon. And so we're going to turn back to our wind source. So our wind source is just a little fan. Our fan has 3 different speed settings. Some fans have 2, some have more. It's easiest to have one that has multiple speeds, so that way you can test your results. And you can record those results on your student worksheet. There's a table here that has your test, and then there's a low, medium, and high speed boxes that you can fill in how many revolutions per minute. And so it does say wind speed measured, so we're just going to put that, like I said, in revolutions per minute. So essentially we would normally talk about it in miles per hour or kilometers per hour, but in this case we don't know exactly how fast they're traveling, so we're going to do it in revolutions per minute, and it's just another form of measurement. So I'm going to turn this on, and you can actually see all these hopefully be able to turn when I turn this on. So I'm going to turn on low first. We want to make sure that we give them good time, so we get our fan set up so it's blowing at them all in a good time. But before we start counting, we want to make sure that it's spinning at an almost constant speed. So you're going to notice that they start pretty slow, kind of like getting out of the bed in the morning. It's a little bit harder, and you get moving. And as you get moving, they start going at a pretty good speed. And you can already see that we have some differences in how fast some of these look like they're spinning. And so our 3-fin one and our 4-fin spoon one over in the back are spinning relatively the same speed. Our 2 in the middle are spinning a little bit faster. And there's some reasons why that is. They have a little bit bigger cup to capture the wind, so they're capturing more of the wind to help them propel. And then there's also more cups too. So you'll see some differences in how they spin. And so for this activity, you're just going to select one of the Animeters that you make to record your data. And then as a class, you guys can compare that data and see, kind of a rough estimate on how many revolutions per minute the fan is going at each of the different speeds. So this is at the low speed on our fan, and I'll shift it up here into medium, and you'll see these guys pick up speed just a little bit. So they're getting them established, so they're clipping along here pretty good. Again, our 3 and our 4 fin are going a little bit slower with the spoons versus the cups, and our egg carton one is just a cruising here. Okay, and I'll turn it up to the high speed. And you'll see here this one's starting to blow over, so you might have to tape them down to the table. That's why we use the vases. They're a little bit heavier, and it helps hold them up a little bit better. And so you can see that they're clipping along pretty well. And so we want to make sure that we can count our revolutions per minute. So I'll use this one and I'll show you what I mean. So there's blue dots on this one. So every time those blue dots go past my finger, I'll count. So there's 1, 2, 3, 4, 5, 6, 7, 8. And you'll want to do that for about a minute. And so you can use a stopwatch or you can have a partner or something time you. And that is the number, whatever you hit at that minute mark, and when they tell you to stop, that is the number you'll record on your table. Okay. So essentially, this is really important to know wind speed for a lot of different things. So in agriculture, we use wind speed with pesticide applications. We want to make sure the wind's not blowing too fast, or maybe it needs to be blowing just a little bit, so that way we can get our chemicals on our fields in a proper manner. If it's blowing too fast, it'll blow it to the next field or to someplace else and maybe cause some damage. If it's not blowing enough, it might just sit in the air and not actually settle down to the ground. So wind is really important. And if you're thinking about the health aspects of times, anybody who suffers from allergies will really know that allergies are worse when it's windy out, because they're blowing those allergens around and affecting us a little bit more. So there's lots of different applications to knowing wind speed, wind direction, and all those different things. So I hope you learned something about wind, and hopefully you guys had some awesome Anometers.